A lump is nothing but a mass of substance without any shape. In this image, you're seeing lumpy mashed potatoes. You cannot see the individual potatoes, right? And you cannot identify a particular region from this entire mess and say that, hey, that part of mashed potatoes came from this particular potato. You simply cannot do it. In other words, it's all together. A lumped capacitance model refers to a system where it is treated to have a uniform temperature. In other words, any spatial changes in temperature within the body is completely ignored. In other words, the change in temperature, if it occurs in the entire body, and it changes only with respect to time. That is why a lumped capacitance system is also called a zero-dimensional system. You need to remember that lumped capacitance is an assumption that is made in problems where the resistance to conduction within the body is insignificant. In other words, if you calculate the R value of such a body, it's going to be very, very low. An example could be a very thin sheet of metal. A thin sheet of metal gets heated or cooled very, very quickly. It's going to have a very low value for conductive resistance. And since spatial variations are neglected, now in a lumped capacitance system, since spatial variations are neglected, it becomes very easy to analyze mathematically. If you do an energy balance, you will end up with the ordinary differential equations that's being shown on the screen. With this governing equation, you can predict the time it takes for the object to change its temperature. Devices like thermocouples are used for transient temperature measurement. They rely upon thin structures of metal that can change their temperature very quickly. Thermocouples would be a great example on which the lumped capacitance assumption can be applied to analyze its performance. Typically, a non-dimensional number called as the Biot number is used to check if you can use the lumped capacitance assumption. Alright, I hope you found this video useful, and I'll see you guys in the next one. Bye.